Here I'm showing a small section of an infinitely large conducting sheet. So we're seeing the thickness of the sheet here, and the sheet runs perpendicular to my writing surface, and it's infinitely large. If we could put a bunch of charge on one side of this conducting sheet, how would that charge distribute itself over the conducting sheet? So let's pretend for an instant that we could put a bunch of charge on the right surface. Let's say plus 4 coulombs per meter squared on the right surface. Well, our intuition tells us that charges are free to move on a conductor, and like charges want to get as far apart from each other as they can, and on a conductive on a solid conductor, the charge always ends up at the surfaces. So our intuition tells us that we're going to end up with a sigma of plus 2 on the right surface and a sigma of plus 2 on the left surface. It's going to evenly split across the two surfaces. But I think we should do it mathematically and see how we get that. So what I'm going to do is I won't make any assumptions. I'll just assume that I end up with some charge on this surface and some charge on the right surface, and I'll call them sigma 1 and sigma 2. So conductors are a little different than insulating sheets, because on an infinite insulating sheet, the charge can't redistribute itself. It has to stay where it is. So you put a couple of insulating sheets near each other, you can treat them individually like there's nothing else around, and then add the fields due to each of the individual components. We call that the superposition principle. With the conductor, what you have to do is figure out how the charge distributes itself first. Once you figure out how the charge distributes itself, then you can treat each side as an infinite non-conducting sheet, and you will get E equals 0 in the center. So let's do that. So I've now figured out that I'm going to end up with sigma 1 on the right and sigma 1 on the left. So there are two conditions. Condition number 1 is that sigma 1 plus sigma 2 has to equal my total. And in this case, my total was plus 4. Because that's what I started out with. I can't get any more charge or lose any charge. It can just move back and forth from the left surface to the right surface. And my other condition is that the electric field is 0 inside the conductor. So there's two unknowns in this problem, sigma 1 and sigma 2, and I need two equations. So I'm going to treat these as if they're two insulating sheets, sigma 1 and sigma 2. And sigma 1 is going to create an electric field. I'll call it E1. That looks something like that. I'm assuming sigma 1 is positive now, but I don't know that for certain yet. But I'll just draw the electric field as if it's positive, and I'll do the same for sigma 2. And I'm going to call that my positive x direction. So now I know that in this region between the two sheets, I have to have E is equal to 0. So I end up with Oh, before I do that, what is the electric field from a large non-conducting sheet? The electric field is going to be the charge density over 2 epsilon naught. You should make sure you can derive that from using Gauss's law. So in the center, between the two sheets, I'm going to end up with E1 plus E2 has to equal 0. And so what is E1? E1 is going to be sigma 1 over 2 epsilon naught. And if sigma 1 is positive, it points to the right. I'm going to put a little x hat here. And I'm going to end up with a minus sigma 2 over 2 epsilon naught. And if sigma 2 is positive, it points in the negative x hat direction. If sigma 2 is negative, it points in the positive x hat direction. So the signs will take care of themselves. So that means that sigma 1 over 2 epsilon naught minus sigma 2 over 2 epsilon naught has to equal 0, which means sigma 1 minus sigma 2 has to equal 0. That's one of my equations. And the other equation I already had written down, that was equation 1 up above. That was that sigma 1 plus sigma 2 had to equal 4. That was sort of a given in this problem, that it started with 4 coulombs per meter square on one side. So there's my two equations, and I've got two unknowns, and I can solve those equations, and what do I get? I get 2 sigma 1 is equal to 4, or sigma 1 is equal to 2, and that means that sigma 2 is also equal to 2. So we showed that the charge density splits when you have a single infinitely large sheet of charge, conducting sheet of charge. The charge splits equally, and the surface charge densities are the same on either side. It gets a little more complicated when other charges are around. So we'll do that in the next video.